Nem rétegbe, legfőképp
Okay, Excellencies, audiences. The next one, sixth plenary session, I'd like to welcome Professor Joseph Horabik from Institute of Agrophysics Police Academy of Science Lublin, with Dr. Jasman Pardede as a moderator. Mr. Horabik, time and place are yours.
Hello. I'm sorry, I'm sorry, Prof. Joseph. You are still unmute. Okay. Good afternoon, dear ladies and gentlemen. On this session, we'll continue our plenary session. In this session, our keynote speaker is Prof. Joseph Horabik, PhD. Welcome, Prof. Joseph. Prof. Joseph, could you please to say hello?
Yeah. Hello, everybody. My name is Joseph Horabik. The best greetings from Poland. Mr. Chairman, ladies and gentlemen, dear friends, it's my great pleasure to participate in the International Congress POITIC 2021. Let me express my thanks to Professor Jono Suhartono, Dean of the Faculty of Industrial Technology, and to Professor Dani Rusiravan, Vice Rector of the Institute Technologie Nationale, for inviting me to participate.
Recording in progress.
Okay, thank you, Prof. First of all, I want to say thanks on Prof. Joseph Horabik, PhD, as our keynote speaker in the current session. We hope in this session we can gain new knowledge from Prof. Joseph Horabik, PhD, and open up our research passion. Now, to give a little overview of Prof. Joseph Horabik, PhD, I want to read a short CP Prof. Joseph Horabik, PhD. Prof. Joseph Horabik, PhD is affiliated to Institute of Agrophysics of Police Academy of Science, Lublin, Poland. And his focus research is on physical property of plant material, mechanical property of granule materials, and their influence of pressure distribution in silos, and discrete element method, modeling and physical properties of agrobulk material, and food powder for safe and efficient storage, handling, and processing, and so on. Prof. Joseph Horabik, PhD, has published his research in more than 80 articles in GCL journal, and he is active as editor-in-chief at the Journal International Agrophysics. So if you want to publish our research in the Journal International Agrophysics, maybe we contact Prof. Okay, it's summary CP of Prof. Joseph Horabik, PhD. I want to know, if you want to know more than about Prof. Joseph Horabik, maybe we can read on his research, or maybe we contact Prof. Joseph Horabik by email. In this session, Prof. Joseph Horabik, PhD, is going to present on his research with entitled Discrete Element Method Modeling of Processes Important for Biosystem Engineering. At this time, we give to you, Prof, on 30 minutes, and then we continue to our question and answer session. It's your time, Prof. Please.
Thank you very much, Mr. Chairman. So as you mentioned, my presentation will be about the discrete element method modeling. The content of my presentation will be as follows: a few words about the biosystems engineering. Next, I will focus on the discrete element method, particularly on the contact models and with special attention paid to bonded particles model. And next, a few examples of application to biosystems engineering, for example, soil tillage, seeding, harvesting, post-harvest operation, and I will finish with some conclusions. Biosystems engineering is a branch of engineering that applies engineering science to solve problems involving biological systems. It integrates engineering science and design with applied biological, environmental, and agricultural sciences. Biosystems engineering.
Excuse me, Prof. Your slide still in first slide.
Excuse me?
You still in first slide, sir.
Well, on my screen, I see the slide number
3.
Number 3, yes.
But in our screen, still in position in number 1, sir, Prof.
Okay. So maybe I should start from the beginning. I will stop to share the screen.
Yes, Prof.
Okay. Excuse me. Sorry. Okay. Which slide can you see? Number 3?
Yes, Prof.
Okay. Thank you very much. I'm sorry for these problems. So, continuing my presentation, I'd like to say that agriculture and food processing are among the biggest producers of final products that are in the form of granular materials. Agriculture, food engineering, harvest, store, handle, and process a very big amount of particulate materials of biological origin. Unlike mineral or plastic granular materials, these materials are usually hygroscopic and change their mechanical properties through the absorption of moisture content. And to predict behavior of those materials, researchers have developed several scientific methods of investigations: empirical, semi-empirical, analytical, and with progressive of development of numerical methods, for example, the final element modeling, which is still a continuum numerical method. And a new method that overcomes the shortcomings of empirical, analytical, and continuum numerical method is the discrete element method, which was developed by Kandal and Strack over 40 years ago. And the method consists of approximate solution of equation of motion of each particle represented numerically and identified with its specific properties such as shape, size, material properties, and initial velocity. And 40 years of development of this method proved its high applicability in numerous branches of science and technology, such as physics, civil engineering, material engineering, agriculture engineering, food science, pharmaceutical engineering. There are a few examples of application to different materials: soil particles, for example, seeds, fruits, fibers, pellets, generally powders, and processes which can be modeled with this method, soil tillage, storage, handling, and processing, next to milling, agglomeration, and so on. A few words about the basic calculation of this method. The source is computational loop, which consists of a few steps which are repeated for each separate particle in very small time increment, approximately about 1 million times per second. Simulations starts with setting the initial position and initial velocity of particle. Next, the contact detection is performed. This is very time-consuming procedure as it increases with number of particles in power of 2. Therefore, very advanced methods were elaborated to reduce the computational time. In the next step, the contact interaction forces are calculated. And in the next step, the gravity and fluid drag forces are introduced. And finally, we obtain the force and moment exerted on each individual particles. And in the next step, with application of Newton's law of motion, acceleration is calculated. And after integration, velocity and new position of particles calculated, and the procedure is continued again in the next step of time. To perform correct calculation, the contact model of interaction between particles and between particles and the working tool is very important, and it's very helpful to calculate this interaction separately in the normal direction, tangent direction, and in the rolling direction. Generally, the elastic, viscous, and frictional interactions are necessary to be incorporated. Elastic and viscous in normal direction, in tangent, the friction should be introduced, and in case of the rolling movement, also the rolling friction should be introduced. Different contact models is necessary to be applied to different materials or to the same biological origin material, but with different moisture content. And for example, for the dry grain, elastoplastic contact model is very useful. It means that deformation starts as the elastic, next the plastic deformation appears, and unloading goes along to the elastic formula. This is not convenient to use this model, as the loading consists of 2 different equations and unloading also with 2 different equations. So viscoelastic contact model is much better, which can be used for the wet grain, and with 1 equation with the dissipation proportional to the velocity of the movement, the loading unloading loop represents the dissipation of energy. In case of the real materials, for example, wheat grain, we can observe from the experiment a very big loop, which represents the dissipation of energy independently on the moisture content of grain. In case of the small size particles, the adhesion forces should be considered in DEM simulation. Adhesion may originate from several sources, including van der Waals forces, electrostatic or liquid bridge. Increase in the moisture content increases rapidly the adhesion. The theory of adhesive Hertzian contact was formulated by Johnson, Kendall, and Roberts 50 years ago. For particles larger than a fraction of millimeter, the most important source of adhesion is a liquid bridge between particles. And for these bigger particles, the linear elastic plastic contact model with the linear cohesion is most frequently applied. Agriculture granular materials present a very wide range of shapes, from nearly spherical to ellipsoidal or to concave particles of fluids and tubes. And the complex shape of particles are often modeled for DEM application by clusters of rigidly joined spheres. This method is known as the multi-sphere method. And this method got a very big application for seeds and generally speaking for agriculture materials. We can see that for wheat, maize, rice, and the other seeds, as well as for a straw model can be modeled with this multi-sphere method. The last 2 decades brought new and advanced method of modeling by introducing so-called bounded particle model. The method was introduced by Potiondi and Kendall. The model is based on the beam theory. It means that particles are connected by the beam, which can transmit both force and moment up to limiting value of the tension and bending strengths. So this approach provides good approximation of behavior of elastic beam, with particularly it can predict exactly the yield location and yield threshold. Very important point of the discrete element method is the calibration of DEM parameters. And some of the basic parameters can be determined experimentally in physical experiments, like modulus of elasticity, friction, restitution coefficient. I mean, experiments with a single particle, if the particle is enough big, or in the experiments with the bulk of particles. But in the more advanced problems, some combined calibration method should be applied. I mean, experimental test and simulation. Comparison of these 2 methods in the same time can provide answer of bulk micro parameters and processes. For example, the formation of natural repose cone, bulk density of freefall bedding, compression test, and so on. And after performing the calibration, we can start to model any process. So now I'd like to briefly to show modeling of some typical processes important for biosystems engineering. Let us start from the soil and impact of the cohesion. In case of the zero cohesion, we can observe
Excuse me, Prof. Joseph.
Yes.
Are you still in the slide content?
I'm in slide 16.
Oh, I don't know. How about on to the another participant? On is same with me on the slide. Prof. Joseph still in the content. Please help.
Yeah, still content.
Okay.
Maybe Prof. Don't by slideshow.
Okay, I'm very sorry. So I will stop sharing this presentation,
Yes.
and I will
Yes,
start from the beginning. Sorry again.
Sorry, Prof. Thank you.
Okay. Okay. What do you see right now? Slide number 16.
Yes, Prof.
Okay. So on this slide, I'd like to show effect of cohesion on the particle behavior. So presented by Tsuji et al. This slide indicates strong impact of cohesion on soil particle behavior during pushing process by bulldozer blade. Okay, I switch to slide number 17. Can you see the slide number 17 right now?
We saw the slide 16.
I'm sorry again. I don't know what is wrong with my computer. So okay, I shifted to slide number 17 but I'm not sure. Do you see the proper slide or not? But anyway, I'd like to shift to the problems of soil tillage and in case of the soil tillage, the size of particles assumed in DEM simulation influence quality of the reproducing of real processes. So smaller size, a better approximation. We can see the images of simulation for the small size particles and the higher size particles. But smaller size means much more particles needed for simulation. So it's very time consuming. But anyway, with the enough big number of particles, approximately 1 million, it is possible to model right now with the advanced software and hardware. Some practical application can be obtained. For example, no tillage seeding operation. can be modeled, and proper size of the opener geometry for this kind size of tillage can be obtained. And particles can be modeled in different way. In case of the soil, which consists very internal structure of the particles. So sometimes a few millimeter particles can be considered as the one particle of the DEM modeling, but sometimes we need to look inside such an aggregate. And this slide provides the behavior of soil aggregates, which is composed of the soil silt cemented by kaolinite. So this is the photograph of the structure with increasing amount of the kaolinite, which fills the pores between particles. The strength of the such a aggregate increases considerably, and as it was shown, DEM modeling can provide exactly the stress deformation relationship, and particularly the profile of the damage of the material. And now let us shift to another process, is storage of granular materials. The simplest process is the discharge of seeds from the silo. So for dry seeds, the elastoplastic contact model applied. For wet seeds, viscoelastic contact model. And we comparing these two graphs, we can see that for dry seeds, a very big scatter of results was obtained, but much smoother line was obtained in case of the viscoelastic contact model. And comparing with the DEM modeling, we can see that both processes for dry and wet seeds can be modeled. DEM was provides also very useful information related to designing of the storage silos, and some equipment which is necessary to provide smooth discharge is the silo inserts, and DEM can provide very useful information concerning loading exerted on the inserts, and also the information concerning the pressure distribution related to the silo operation. One important point, and the most danger point of the process of discharge, is the initiation of discharge. Granular material does not start its movement immediately in the entire silo, but the so-called rarefaction wave propagates from the bottom to the top. And during the propagation of this wave, the particles below the front of this wave is moving, but the stagnant zone is still upward. And this is related with very high pressure switch on the wall of the silo. So it is very danger moment. The speed of this wave is about 50 meters per second. So DEM is very useful for providing deeper insight in this process. Another process successfully modeled is the commingling in bucket elevator, segregation and mixing of grains. So again, experiments performed for soybeans proved very good agreement between experimental and simulated results. It means the uniformity of the mass of bulk of seeds with time of the elevator mixing. Another example, handling of the materials and bruise damage of apple seeds. Schaffer et al. Showed that bruise damage of apple seeds during repeated impacts loading can be effectively modeled with use of the viscoelastic contact model and with the multi-sphere method. Bruise volume increases almost linearly with the peak force exerted on that particle. And another important process, harvesting and desteaming of grapes. Grapes are modeled as the spherical particles, but the steam are modeled with the application of the bonded particle model, and them proved to model properly the commercial work of the commercial desteamer. Another application, harvesting, grain straw separation, grain modeled as the spherical particles, straw as the segments connected by the BPM model. And again, we can see good approximation of experimental results by them simulations.
Joseph, we now show only the slide 17.
Oh, I'm sorry. I don't know what is wrong with my presentation. I'm very sorry. So, well, I'm afraid that I cannot improve this. So
now is slide 28.
28.
Yes.
Okay, let me try again.
Also slide 28.
Okay. Okay. So this slide is about compaction of fibers, but anyway, the time is going quickly, so I will come to some final slides. Well, another important part of modeling is the processing and the determination of the strength of the, for example, pellets. This method was appeared to be very useful in modeling of the objects treated as the BPM particles, I mean, connected by bonded particle models. And this concerns both the, for example, the starch tablets and some different behavior, for example, ductile, semi-brittle, or brittle behavior can be modeled with this approach. And coming to the final remarks, I'd like to say that there are still some challenges in improving efficiency of the modeling. The very complex behavior of biological materials and strong dependence of properties on moisture content requires development of more advanced contact models capable to describe better dynamic of the processes. And for sure, advances in them and finite element method coupling are needed to improve, for example, multi-scale modeling of practical scale problems, and advances of them and computational fluid dynamics coupling would improve modeling of processes involving interaction of discrete matrix with gas fluid phase, such as fluidization, pneumatic conveying, and heat transfer. And coming to conclusions, I'd like to say that DEM has proved to be effective in studying numerous technological processes in biosystems engineering. It allows insight into mechanism of stress transmission in granular solids that enables investigation of effect of properties of individual particles on behavior of bed of particles, and particularly the bonded particle model reproduce many features of behavior of solids like elasticity with ultimate yield, hardening, softening, and fracturing. So thank you very much for your kind attention, and I'm very, very sorry for the disturbance of my presentation. So I couldn't improve this during the presentation. I don't know what happened with my computer for that time. Thank you very much.
Okay, thank you very much, Prof. Joseph. Now, to all of participants, please, we hear the next presentation from Prof. Joseph. Now, please to give question to Prof. Joseph, please. Ladies and gentlemen, please.
Hello, Joseph. I am very glad to see this part of your presentation. I think that it is very high-level modeling of many processes, and I congratulation to your company and also to you, because I saw it is a very, very great work, and I hope in the future I will see all the presentation, and it was very, very interesting. Thank you.
Thank you.
Dear Professor Hlavatsova, thank you very much for your kind words. I think this method is very promising tool for the future, and we are glad to be able to participate in this progress.
Okay, dear ladies and gentlemen, any question again to Prof. Joseph? Didn't? Not yet? Maybe on presentation Prof. Jacek is more clearly. So not any question. I hope the conclusion from the Prof. Jacek to give our participant, please, Prof, on ending session. end the session remark. Anything on Prof. Jacek we want to say to our participant? Prof. Jacek?
No.
No, enough? Okay. Thank you, Prof. Jacek, for the nice presentation. And I think
Thank you very much.
our session is on. We will end, and I give turn back to my Master of Ceremony, Miss Tati. Miss Tati, it's your time, please.
Thank you, Mr. Seres and Mr. Pardede. I'm sorry, Mr. Horabik. Now, Excellencies, ladies and gentlemen, here we will have the parallel session. And for those who join the parallel session, please join to each room.
Okay, our next keynote speaker is Professor Isvan Seres. Professor Isvan Seres, are you there?
Yes, thank you. I'm here.
Okay, thank you very
much.
Thank you very much, and good morning in Hungary. Yeah.
Yeah, thank you. Okay, I just share my screen.
Yeah.
Be able for you my presentation.
Yeah. Professor Isvan Seres is from Hungarian University of Agriculture and Life Sciences. Without any further delay, I will like to invite Professor Seres to deliver us with the presentation. The floor is yours, Professor Seres.
Thank you very much. Could you give just some feedback that can you see my presentation?
Yes, I can see your presentation.
Okay. Thank you. So, dear colleagues, ladies and gentlemen, my name is István Seres and I'm working in the Gödöllő in the Hungarian Agriculture and Life Sciences University. And our department is working a lot with different renewable energy sources, mainly with solar energy with the leadership of Professor Farkas. And now I would like to show you a few work about what we did. Actually, I was thinking a lot what to do when I was watching the topics of the conference, that we do different project work with microcontrollers as well. But I think the solar energy is most dominant for our department, so I decided to give you some impression about our work on that field. Actually, what mainly I would like to show you that we installed a 10 kilowatt peak photovoltaic system on the top of one of our student hostel buildings in 2005. Here are some just pictures from about the construction of the site, and here you can see some different datas. That time, this was the biggest Hungarian photovoltaic system. Of course, since that, the technology is improving very fast, as we could see from several presentations, how big is the improvement. We can see it in our university as well. Now, altogether, we have 600 kilowatt peak installed on the roofs. And even in Hungary, we have some bigger constructions, mainly operated by professional companies. Even me, I have a small system in my house as well. So why I was choosing this old and relatively small system? Because we could collect a lot of consequences about the working of it, and perhaps this can be interesting about the aging and how the power is changing and what sort of factors we can see. First, just let me show a few details about this system. Altogether, we have 150 square meters of modules. Most of them are Hungarian-made amorph silicon Dunasolar modules that companies not working already in Hungary, and a smaller fraction of the system is made of German polycrystalline modules. Here you can see some details about the size of the system and the numbers and the power. I will give you a few words about the newer system, which is a transparent module, semi-transparent module system in front of our Aula building. There the capacity is much less, 3.3 kilowatt peak. That is a demonstrational system, not really for energy production. Of course, we produce energy with it as well, but we wanted to meet the students every day with this technology because the other systems are on the rooftop, so they cannot meet with them. And of course, in our research lab, we have different smaller modules, different testing sites to check the technology. We did different measurements. Oh, sorry, I'm just not sure that you can see my whole figure or not. I hope so. So we have different, we did a lot of different measurements. Even in the education, we have these measurements during the physics lectures that the student has to measure the characteristics, the IV characteristics of the modules, and calculate the maximum power can be get from that module, that given module, and even we can show them why it is important not to shade the modules, because if we just shade one cell, for example, then the module power coming down very drastically. So these figures are showing the effect of the shading under different geometries. Of course, these all types of module, they just had one bypass diodes. In the newer ones, more diodes are installed, and it can decrease this effect. On the other hand, we were investigating, or we made a comparison of the different systems, different technologies as well. For example, as I showed you, in this system, we have polycrystalline and amorph silicon modules as well. Of course, the direct comparison of the energy production is not the best because they have different nominal power. So what we did, we defined a so-called specific power, which specific power is the actual power of the system divided by the nominal. So we watched that 1 kilowatt peak of module capacity, what power with what power is working, or how many energy is produced by 1 kilowatt peak of modules. So the energy production was divided back with the nominal power of the system. In this way, we got specific power and specific energy production, and we checked the rate of these productions. That means that 1 kilowatt peak of polycrystalline powered energy was divided by the energy production of 1 kilowatt peak of amorph silicon. And what we could see, this is data of long years, what we could see that there is a seasonal effect in this function. Of course, yeah, in Hungary, I'm not sure if you know it. In Hungary, in the summertime, we have generally above 30 degrees, 35. And in the wintertime, sometimes we have -10 as well. So surely there has to be a temperature dependence in the problem. But we saw that there is a spectral dependence as well. That means that in the winter time, the solar radiation has to cross much wider air layer, and in this way the spectra is changing. So we made some spectral measurement. We have a
Putra or Sterwin.
Okay, I saw that there is a problem somewhere. Okay, so we have a spectrometer. I just show it in this way, and the spectrometer can measure. Yeah, it's not a very wide range, but it can measure from 400 nanometer to roughly 1050 nanometer the distribution of the incoming light. With the spectrometer, yeah, perhaps we are online. I think I can show you some demonstration as well. Just one more moment for that one. Oh, sorry. I cannot start my. I just want to start the software, but I cannot at this moment because it's not running. Oh, it's a shame. Okay, perhaps if we have some time in the end of the, because I cannot use my computer, so I could not reach my software at this moment. Okay, no problem. I did not used to use the Zoom, but in the end of the presentation, perhaps I will show you if we will have time. So with this spectrometer software, we can analyze the incoming light, I mean the power distribution. Actually, this unit is calculating the photons, how many photons were coming during a given time. This time can be adjusted in a special wavelength range. And in this way, we can measure what is the spectra of the incoming light. And we were using different sheets to cut a part of the spectra, different colors, we can say. And even we were measuring the incoming radiation coming to the photovoltaic modules. And we were measuring the reflected radiation spectra. And from the difference of them, we could analyze which type of spectra is absorbed by the module. So we were analyzing the spectral dependence for the different technologies. For example, for this given example, what I showed for you, that there was a seasonal effect in the rate of the different technologies energy production, we could see that the amorph silicon modules are more sensitive for the red and infrared radiation than the polycrystalline ones. We did a lot of measurement, and some students' work, some diplomas was made of this. So I think it was very useful for the education as well. As I mentioned, this is an old system, and what is the reason to use an old system? That is to check the degradation. It's a big question. Of course, I know that the producers are using artificial aging, and they want to test their system, what can be the reasonable lifetime of these products. But no, in our system, we have actually, at this time, we have 17 years old modules installed, or even older, because some of the modules was bought earlier. We did not have the total money at once, so we were collecting the modules for years. And So we can say that almost 20 years we have these modules installed at the same place. And under Hungarian conditions, I think this can give some good results for the aging. The energy data, of course, we are measuring different data. We are measuring continuously the energy production. We do not measure continuously the power, but we save energy data in every 10 minutes. Here you can see how much was the, this is the date and the time when that measurement was done. This is the identifier of the unit. And these are in kilowatts, the energy production of the different subsystems. So these measurements is running continuously, and we are measuring the DC side, and even we have a special meter measuring the grid. And on that side, we are measuring the AC side as well, how many energy was fed into the electric grid. And we use a three-phase system, so the three different subsystems we use goes to the three different phases. So in this way, we can measure separately how much energy was taken during that 10 minutes to the grid. So from these data, we can calculate 10 minutes average power for each subsystems. Of course, we try to get, or we try to check if how much is the degradation of the system. This degradation is normal, I think. If you buy a photovoltaic system, for example, I installed one, as I mentioned, on the roof of our house last year, and the warranty was that these modules will have the 85% of their initial capacity or nominal power after 20 years. How we can check it? Okay, we checked it in our system. This is the daily energy production of our system. Here you can see very well the seasonal changing. Sometimes we had some data loss, a bad disaster, so the system was working continuously. These gaps are not the system fault, but they are just data loss of the system. But as I mentioned, we measured these data for the different technologies separately. So this was giving the basic of our analysis. And so as you see, we did some measurement and we made some yearly analysis of the data, how much energy was produced from year to year. At the beginning, it was very regular. I mean, in every end of the year, I was coming here. In the later time, it was not so regular, but it was working continuously. So we can go, or we can say how much was the total energy production during the operation. And even we can calculate how much was in a given period. So in this way, we made a comparison of the different subsystems. In this slide, you can see the differences between the two Dunasolar subsystems. These subsystems are theoretically identical. However, one part of it is slightly higher than the other part. In the last period, we had a phase problem that we could not recognize it. That is the reason why I did not use this in my calculation. They are identically the same, or theoretically the same, but of course there are some slight difference between them. What can be the reason? We know that the nominal power of these modules, but even during the tests, that I think because of the production, there are a few % of differences between them. And one problem can be that we have rows of modules. And in the winter time, of course, partly these rows are shadowing each other. However, we were calculating that the shadowing would be minimized, but in the winter time, it's not possible in the morning and in the afternoon because the sun is going so low degree, small inclination degree. So there are some shading that period, but not in the first row because it is in the top of the 4-story building. So that can give a difference between them. But I think they are working more or less together. The other, perhaps more interesting, if we compare the polycrystalline technology and the amorphous silicon technology. Here the difference is bigger than in the case of 2 Dunasolar rows, but the polycrystalline technology subsystem has bigger nominal power. So that is normal that it produces more energy. But if we compare the specific powers, we just made a rate of the comparison. We compared the rate of the polycrystalline technology and the average amorphous silicon technology. And in statistics, after 70 years, we could see a definite decline in this rate. That means that, yeah, the Dunasolar, also the Dunasolar is the amorphous silicon over the polycrystalline. So it is decreased. That means that the rate of the polycrystalline technology in the energy production is increased. I just show it in a different slide. In this slide, you can see what is the rate of the polycrystalline technology in the total energy production. And yeah, what we can see that it is going from about 40% to 43 point something percent. So our conclusion was that the amorphous silicon technology degraded more than the other modules. Yeah, of course, each of them was degraded in a given scale. What can be the reason for it? So we are checking regularly the system, and these are the ASA, the polycrystalline modules. And on that way, when we checked the system, there was no any sign of degradation. So visually, we could see nothing. Of course, what you can not see by eye, that there is, for example, the effect of the UV radiation. Ultraviolet radiation is damaging the material somehow, but you cannot see it. So I think the polycrystalline modules are okay. What we could see that during the construction, they did not use the rust-free screws. So that was the only problem we should repair. But it does not have effect on the working on the system. After that, we were checking the amorphous silicon technology as well. We could not see colorization. The junction seems to be okay. There are no hotspots on the system. But what we could see that I think because of the production technology, in the bottom and the top of the modules, some air was going in. I think the insulation material is not the best. So between the module surface and the glass cover, there are some air bubbles. And of course, these air bubbles will decrease the useful energy, because when the light is coming to this region, then because of the total reflection, you can know it from the physics, a big part of the light is reflected back, as you see here. When we see the black color of the module, that means most of the radiation was absorbed. Yeah, of course, from the glass we have reflections. You can see even here the clouds. But here, the biggest part of the light is reflected back from these air bubbles because of the total reflection. And of course, if it is reflected back, then it cannot go to the absorber surface of the module. That means that this part is not working properly. In some cases, we could see this effect almost in all rows, and in other cases, it was very, very partial effect. This is a photo of the system from before, and you can see that in the middle of the field, very few module is affected, mainly in the sides, generally in the sides of the system, and in the black part of the system. I made an analysis. This is the last row. In the last row, almost every module is affected. But if I go further, just the side modules are affected. We were thinking, yeah, these are the numbers. This is the source direction, and this is the north. And in the rows, in the north part, are affected in high range, and the rows in the front size in the south side of the system of the field is affected less. And even in these rows, mainly the side module, which are in the edge of the rows, that are affected. So we were talking about what can be the reason for this, and we concluded that probably probably the wind direction in Hungary and in Gödöllő as well. The main wind direction is from north, and as the wind is coming, in some cases we have quite strong wind. These Duna solar modules, I'm not sure that I have a photo about it. Oh, no, not. These Duna solar modules, the fixation point is somewhere here. And of course, if the wind is coming and some turbulences are developed, then it is moving continuously, I think, the three sides of the modules. This problem does not come for the polycrystalline, because the polycrystalline has a frame, and this frame does not let to move the module itself, but not for the amorph silicon. So the fixation points, there are 4-6 fixation points somewhere here. You can see the holder rod behind, and this is a glass. If the wind is coming, it can move a little bit slightly. Of course, you cannot see by eye, but I think that can move, and that is the reason why the side modules and the backside modules from where the wind is coming are mainly affected by this problem. So we predicted that this calls for us about 4% of energy loss continuously at this moment. Perhaps we should try to re-insulate some modules to see that it stops, or we can stop it or not. That is the next question. Okay, to go ahead, beside the quantity questions, I have forgotten to take my phone to silent mode, but I didn't know. Okay. So beside the quantity question, we tried to see some quality questions as well, because as we are using more and more electronics, the grid quality is an important mention as well. Traditionally, our electric grid is powered by generators. Yeah, I teach physics, so in every presentation I have to take some physics. In the generators, we are rotating coils, and in these rotating coils, the flux is changing continuously. We can write the electric or the magnetic flux of this coil, and as it is rotated, the time derivative of this flux will give us the voltage. But as in the flux, the angle of the magnetic field and the angle of the coil is important, and this angle is changing continuously. Actually, the surface perpendicular component to the magnetic field is important in this case, and it is changing as a cosinus function. But if we derive this function cosinus, then we get a sinus, and in this way we get why in the electric grid we have a sinus function. And yeah, the magnitude of this function is important as well, but the periodic time is important as well. Yeah, the reciprocal value of this periodic time is the frequency. That is what is very important for the working of, yeah, not all, but some units. This frequency in Hungary and in Europe is 50 hertz, but it can vary in the world. In America, for example, they use 60 hertz as a grid frequency. So actually, we made with students a very simple measurement circuit. To measure this sinus function is not so easy because it is changing very fast. You cannot check it with a multimeter. If you met with an oscilloscope, with the oscilloscope you can visualize it very easily. And even with newer oscilloscopes, you can save the data as well. But these types of oscilloscopes are not so cheap. So with students, we were using high sample rate voltage measurement with data loggers. But the problem that these data loggers can accept generally maximum 5 or 10 volts and an input voltage. So we were setting up a voltage divider, 2 resistances connected seriously. And from the physics, you can know that in the resistances, the voltages are proportional to the resistances in case of serial connection. So we were taking this unit, we were connecting the grid voltage to the serial connection of these two units, and we were measuring just the voltage of R2. If we use this 46 kilo ohm, then 0.46 kilo ohm, high resistances had to be used to avoid high currents. Then, yeah, it roughly 1 to 100. Then the power rate or the voltage rate is 1 to 100 as well. In this way, we could measure how much is the voltage as a time function. We were using 2 types of units for this purpose. This is a National Instruments USB. It's a very simple one, which can measure with 48 kilosample per second. And we were using National Instruments MIDAC unit. This is educational unit for what the sampling frequency is 400,000 sample per second. And with these units, we were measuring, we used the LabVIEW software for collecting the data. And with this one, we could measure what is the time serial of the voltage. This is the measurement of the voltage of the grid in the physics lab. And with this one, we could check what is the shape of the voltage function for different inverters produced by solar energy. For example, this is a very simple inverter. We have a so-called Solas use case. In this Solas use case, we installed a few small PV modules, about 5 watts altogether, and a charger and an inverter. And this unit is borrowed for the scouts, and when they go to camp, they can charge their telephones and they can operate a LED or for lighting and so on and so on. For we checked the simple inverters. The simple inverters are not sinusoid generally, but the normal units, chargers and lamps are working with it. But the problem that I just check how many time I do have. Okay, perhaps I can stop for a while now, because I would like to show you something. Theoretically, this is an audio software. With this audio software, I would like to demonstrate for you what we measured. Actually, okay. Actually, this is, oh, I made a mistake. No, don't problem. I can open it again. So I just play a sound for you. I hope that you will hear it. Could you give back? Could you give any feedback? Could you hear the sound?
No, no,
No.
we
There
cannot
is no.
hear.
Oh, it's really a shame. Okay, then this demonstration will just work by picture. Sorry for it.
Yeah.
The problem that, yeah, I cannot get the, yeah. So this is a sound of a violin. I'm really sorry that I could not demonstrate it, but I don't know how I should set my computer to be able to hear the sound of the violin as well. And this is, it was recorded and we can analyze it. Because the main question, if we hear a violin or if we hear a piano, we can decide which instruments sound we hear. However, they are playing theoretically the same sound. For example, this sound A, 440 hertz. And for that one, with this software, I can show you the spectra. The spectra shows what sort of frequencies was using in between. This is the spectra of the violin. I have 4 children, so they play different instruments. Yeah, at this moment, we can see that, yeah, this was about 440 hertz, but I could not find exactly the, yeah, 440 hertz. This is the peak, but we have 880 and we have 1320 and so on. So when we hear a sound, we hear the basic frequencies, and we have the double, 3 times bigger, 4 times bigger, and so on frequencies as well. If I open another instrument, yeah, this other instrument is a piano. Surely you would be able to hear, but at this moment, perhaps it's useless to play, but it's really that. And if I check the spectra, then in this spectra, we can see very different range, but the same. The basic frequency is 440, and we have so-called harmonics. So the harmonics is generated as well when we hear a sound. And as the rate of the harmonics are different, we can distinguish which was the piano and which was the violin. So in this way, we can recognize what sort of instruments was working. Okay, this was about the sound. Now I'm coming back to my presentation. No, I don't want to say. So this is a spectra of the piano, and this is the spectra of a violin with a different software. So what we can see, what is the difference? The difference is the power rate of the harmonics. But these harmonics are existing for any system when we are generating periodic functions. Perhaps some of you were learning mathematics, and perhaps you have learned the Fourier analysis theory. In the Fourier analysis, it says that if you have any periodic function, this periodic function can be reproduced by a special sum of sinus and cosinus functions. This is the so-called Fourier serial. And even we have the rule how the multipliers of the sinus and cosinus functions has to be calculated. And what we see that in this case, I have to multiply the x by whole numbers. If the x is a given frequency, then I have the multipliers of x. So I have the harmonics. In this way, we can set up the spectra of any periodic function. In some cases, we have even functions. We call a function even when it is symmetrical to the y-axis. And we have odd function when it is symmetrical to the origo. As a sinus function is odd function and cosinus is even. In this way, we can use each. Okay, so I showed you that with a very simple data logger, we started to analyze the grid, but it was not enough to check the harmonics. So we were using a professional unit. This is an electric power quality analyzer, Wally free. Wally is the name of this unit. And our PhD students, Atsu Divine, was doing these measurements. This unit can measure the voltage and the current and even the phase angle between them. And it can analyze the harmonics and the rate of the harmonics in a given frequency. And what we were calculating the total harmonic distortion. It's an important quality property of the generated, where V1 is the voltage, maximum voltage of the fundamental frequency, and Vi, where I goes from 2 to 40, is the voltage of the harmonics frequencies. Theoretically, the summarization goes to infinity, but the amplitude of these voltage functions are coming down generally exponentially. So after a while, we can eliminate it. A few words about this analysis. First of all, there are some standards for this one. How much can be, we have different standards, European and American standards. How much can be the harmonic content in the smaller orders and in the higher orders? And what you see, the odd components and the even components are different. I mean the limits. If we check the different standards, generally they say that the total harmonic distortion has to be below 5%. Why? It's not interesting if it's odd or even. because this is the basic frequency. This is the first harmonic. If you check the first harmonic, in the first harmonic, the frequency is the double, so the wavelength is the half of the original basic fundamental function. But in this case, the harmonic gives a positive and a negative addition in one part, so they more or less equalize each other. But if we check the second harmonic, in this case, in this 1/2 period, I have 2 positive and 1 negative range. And in the other side, I have 2 negative and 1 positive range. That is the reason why these harmonics are more strict calculated or more strictly reduced than the other ones. Yeah, this is the inverter and the measuring of the transparent system. We did a lot of different measurement, and here you can see the harmonic distribution, and you can see the total harmonic distortion of the system for the voltage and for the current. What we could recognize that under bad radiation conditions, the total harmonic distortion was higher, and under good conditions, the total harmonic distortion was in the limit. And we could measure the same for the big 10 kilowatt peak system as well. So we could say that the total harmonic distortion is below the expectations when the sun is shining well, but it can go wrong for our inverters. Of course, it's depending on the inverters under bad conditions. But if the condition is not so good, the radiation is changing, or the radiation is very low, then of course we feed very small amount of energy to the grid, so we cannot harm too much for the grid. But under good condition, when the energy surplus is big, then the total harmonic distortion is okay. That means that our systems do not harm for the grid. So the grid operators don't have to be worried about it. Okay, I think at 10 o'clock, so I finished my presentation. I was writing some conclusions, but I think I don't have to summarize it. I hope it was clear. So thank you very much for your kind attention. And I'm coming back for the...
Okay, thank you very much. Okay, thank you very much, Professor Seres Isvan. Now I open the question and answer session. Are there any questions from the participants? From the audience?
Hello.
Yes.
Hello, István. Your presentation was very interesting.
Nice to meet you, Susanna.
Experiment, and the piano we heard the piano. All the violin note, but heard the piano was good. I have one question only. You said that you have also solar system on your house, and what is the amount of energy you get from the solar system? It is enough for your house or no?
Yeah. Actually, it's not exactly optimal. Its nominal power is 4.4 kilowatt. The module capacity, but the roof is facing a little bit to the east and south, so it's not exactly optimal, and even the angle is not optimal for Hungary. But even this way, yeah, it's not exactly. I do not have measurement data for 1 year because it was installed last November, so we have a month back yet. But I think with this one, I can produce, so the system produces roughly 5,000 kilowatt hour per year. But actually our electric consumption is less. It is about 3,000 kilowatt hour. Yeah, the children was leaving our home, so it was coming down. So actually, we were installing now some climate unit for what we can use for cooling the house and heating the house as well. So the difference, no, we are heating the house with that one. Okay, one room with that one. So I think it's this amount of energy is fairly enough. I'm even hesitating to change my gas boiler to electric one. So I think a small system, and it is 13 modules, so it's not a big one, but it can really operate the house with electricity.
Thank you very much. Thank you.
Thank you.
Yeah. Okay, thank you very much. Since we have a short of time, I think we will close our session. I thank you very much for all participants and for keynote speaker. Thank you very much. And I will return our time to the organizer.
Okay. Thank you, Mr. Alexin and Professor Saras. Well, ladies and gentlemen, coming up to the next session, we are going to have a parallel session. For those who join the parallel session, please join to each room. Thank you.
So we can start now. Professor Seres is already here. Okay. Hello, everyone. Good afternoon and good morning for Professor Seres. Welcome back again in the afternoon session. We have 7 presenters because we have 1 additional presenters today. So we have 7, and in the afternoon session, we have 3 presenters. Okay, ladies and gentlemen, good afternoon. First of all, I would like to thank the Honorable Chair of Parallel Session, Professor Seres, Mr. and Madam speakers, distinguished guests, fellow students, and all audience. Welcome you all to the prestigious annual conference, the 3rd Faculty of Industrial Technology International Congress 2021, and hosted by Institut Teknologi Nasional Bandung, Indonesia. Ladies and gentlemen, all presentation and discussion in this parallel session with the topic about electrical engineering power and education technology will be led by our moderator, Professor Isvan Seres. Without further ado, please welcome Professor Isvan Seres. The time is yours.
Thank you very much, ladies and gentlemen. Welcome you in this section. and I think we should go the work. I will, as I see in the program, our first presenter would be Nasrun Haryanto, and the title of the presentation of Design of Solar Energy for Street Light. Please.
I think Nasrun hasn't appeared in the participant list here. Wait a second. I will contact him.
Okay, thank you very much. We are waiting.
He's still providing his network and slide.
If there is any technical problem, but perhaps we can change the order. What is your opinion?
But I saw him.
Oh, then it's
saw
okay.
him.
Okay, then it's okay.
But he has gone again.
Good.
He's
good,
left
good. No,
again.
no problem. No problem. We can wait.
For Professor, we can jump to the next speaker maybe while we are waiting for him.
I think so as well. Okay, then if you don't mind, we make a change in the order of the presentations because perhaps Nasrun Haryanto has some technical problem with the system. So then I would like to ask Anissa Maulidia, Lita Lidaiveti, Lucia Jamboli, and Lisa Christiana. I don't know exactly who will be the presenter. The title of the presentation is Analysis of Logistic Regression Algorithm for Predicting Types of Breast Cancer Based on Machine Learning. Thank you.
So I think Anissa is the same. She's not here. I think we can skip again to the
skip again. Then we can go to the last presenter. Theoretically, last but not at least. Then I call Liman Hartavan, and the title is Design of 2D Frame Simulator and Control System with Gyrosensor. Liman, please, if you are here.
Excuse me, Professor. Anissa Maulidia is here.
Then who is here? Then we start with that one. Okay. Good, good.
First in, first out.
Then Anissa, please share your screen with us and take your presentation. Thank you.
Anissa, your turn now.
Thank you. I'm so sorry, apologies. I'm late.
No problem.
Before I start the presentation, I have permission to share screen first. Okay, Assalamualaikum warahmatullahi wabarakatuh. Thanks to the moderators for the opportunity, the honorable all audience and presenters who are present this session. It is an honor to be a presenter in this international conference, FOITIC 2021. I am Anissa Mulydia from Institut Teknologi Nasional Bandung. Allow me to present the paper entitled Analysis of Logistic Regression Algorithm for Predicting Types of Breast Cancer Based on Machine Learning. This paper collaborating with Ms. Rita Ridiawati, Ms. Lucia Jambola, and Ms. Lisa Christiana. And this is what our research has been looking at. The first slide shows the background of why this research was conducted. The first technology development in the health sector is now that artificial intelligence is currently getting more attention in various sectors, one of which is the use of machine learning field of health. The transformation health system has many challenges, increased disease burden and greater demand of service health. The fundamental transformation of the health system is very important to address the challenges that exist to achieve universal health coverage by 2030. Machine learning is a manifestation, the most tangible from artificial intelligence that can overcome these challenges in the form of digital technology that can provide greater effectiveness and efficiently health system. And the second, machine learning has high accuracy with can reach 97%. And last, breast cancer is one of the cases in the health sector that have a high diagnostic error rate around 10 until 30%. And based on this statement, an alternative is needed as a transformation health system that can help predict the process so as to reduce the diagnostic error case. And it is based on a World Health Organization statement that the initial diagnosis of cancer must be accurate because it will determine the next treatment path for the patient. And the research objective is to analyze the accuracy and performance of logistic algorithm regression used in the case of the machine learning based for breast cancer prediction with evaluation method, cross-validation, confusion matrix, ROC. And now we are at the knowledge about data set which are used in this research. Data set used in the Wisconsin breast cancer diagnostic data set taken from a machine learning repository where the link is listed on the screen. The simple size dataset is have 569 sample total, 30 dimensionality, and 2 number of class. There are class benign and malignant. And this research using Jupyter Notebook integrated with Python programming language consists to stage in general at machine learning. There are 2 stage, training phase and testing phase, and the data is divided using programming machine learning function into 80% for training and 20% for testing. And this is the stage or methodology of the research. The data set has been inputted the programming system will enter the pre-processing stage, and the data processing stage, there are 2 stages, data cleaning and data transformation. Data cleaning is used for the missing value process, which is missing value is data doesn't have complete attributes, one of which is marked by having an empty values, and this data set marked by none or not a number. And the second stage is data transformation, namely the process of converting data into a logic 0 for benign class and 1 for malignant class. There is also transformation of several functions from training data to the testing process. And the next, after the data preprocessing, the stage is feature scaling, which is data preprocessing and feature scaling are carried out by training data in the programming by using a transformation function. In reality, the testing phase is only really testing the model that has been formed, including the entire series of preprocessing and feature scaling. The standardization has used this paper to feature scaling, so that numerical data is the same scale, so that it will make it easier for machine learning to computation by only oscillating in the data is scaled the range 0 to 1. As we can see at the screen, the result of feature scaling or feature has been scaled between 0 and 1. And here the data testing process, there are two important things. Rules as a syntax that has carried out the training process, where the rules will be used as a function that will test an algorithm using the data. And this is X-test, where the data has been splitting in the first. X-test is to 20% of all data. And then process with function, and the output of the testing phase is prediction or classification of the type of cancer, which is evaluated through 3 methods, which is cross-validation, confusion matrix, and ROC-AUC. And this is a result about this paper. From this paper, the slide showed the accuracy result in the training process. And the accuracy resulting from the cross-validation process. By using the same data, it can be analyzed that the training process is overfitting, one of which is indicated by the accuracy of the training data is being greater than accuracy of the cross-validation process. We can see that training data accuracy is 99% and cross-validation accuracy is 98%. And the next evaluation method is confusion matrix. There are 2 sections, actual class and predicted class. There are highlight 2 type error type 1 and error type 2, but error type 2 is more dangerous than error type 1 because in the error type 2, the predicted class is negative or benign, but the actual class patient is positive or malignant class. So that patient will be prevented from receiving real treatment. And the next is the value of parameters, accuracy, precision, recall, and F1 score of testing phase. The values are more, all values are more than 0.5, 90, 50%, and great for making prediction. The parameter value is getting close to 1. It means that performance of algorithm model is good. And the next parameter is ROC-AUC. The value of ROC-AUC is 0.965, or included the excellent category, where the algorithm can prediction from 1 and 0 very well. And the RSMA and the root mean square error show the error value the algorithm in the prediction process, which is based on the root difference of the predicted value and the actual value squared and divided by the amount of data. While the RMSA value shows the number around 90%, the closer to 1, the better the error value. And this is the summary of the overall parameter values in this study. Based on the research that has been done, logistic regression has a very good ability to predict the type of this cancer, which is indicated by the test data accuracy value of 96.5% and can generalize to new data formation by 89%. In addition, the ability of logistic regression in providing information according to the requested data precision is also very good, about 95.7%, with the ability to find information or recall of 95.6%, makes logistic regression able to support predictive data as 1 and 0 by 96.3%, and with an error value of around 90%. And this is several references that I use in this paper. That's all for me. Thank you.
Thank you very much for your interesting presentation. And I would like our audience to ask questions or remarks if they do have. Anybody? No, why they are thinking? Just let me ask something. Yeah, I teach physics, and they say that the last century was the century of the physics, but this century will be the century of the biology. So I think if you are working with living things, the problems are much more complicated. So congratulations. And I think it is a very important topic, what you do. I just would like to ask one thing, that if I remember well, you were analyzing 560 something data. I did not wrote it down. And in our thing in the technology, we used to use much more data analysis. What do you think? What is the number? What is necessary for teaching? I saw that 80% of the data was used for teaching, the algorithm, and 20 for testing. But this technology perhaps can be used for other things as well. What is the minimum data set you need to be able to teach this algorithm? Oh. Yeah, perhaps Anissa has some technical problem because as I see, she disappeared. Okay. Then perhaps we can ask her later on. Good. Then I think we can move to the next presenter. Lita.
Yeah, Professor, Nasrun already here.
Nasrun here?
Yes.
Then
yes.
Okay. Then,
I'm Nasrun. Okay.
Hi, thank you very much for joining us. So Nasrun, please, then we would like to listen your presentation about design of solar energy for street light.
Yeah. Yeah, thank you for your give me a time for presentation. Good afternoon, everybody. Yeah, design of solar energy for street is my research. Is this latar belakang background ya. Street light is community service. Business activity, promotion, safety, and security, and aesthetic. Street light has an important role in supporting community activities, like that we use in the culture of village development. This is purposes design of solar for street light, increasing community economic activities, reduce the risk of traffic accident at night, improve the safety of pedestrian traffic at night from criminal disturbance. Street-like location is a village in Kuta, Mertak, Kadana, Sengkol, and Prabu, Puja sub-district and Central Lombok district. This is the this is the village Prabu, Kuta, Sugadana, Mertak, and Singkol. The diagram block diagram of solar panel plan proceeds as a solar panel into the control BCR and CC battery to CC, go to CC to control. When the battery is full, the controller off the supply power panel to battery, and when the battery full, and then at the night the lamp is bright. Definition of battery capacity: electric energy of battery 1.2 PLT. A battery energy, electric energy of battery. Load power, we determine the load power watt and use time hours. The capacity battery, but the ODPS where the UD depth of discharge about 80%, system protect about 12%. Determinant of the panel capacity, we have the index sun index. We have the sun index from the Mataram Indonesia Solar Energy Surface Meteorology. We have the from internet, the alternative climate and environment. The fever from NASA. This from the index we have the height index 6.23. The capacity of solar panel we can calculation of solar equal a battery for isolation. This is sun index. The planning criteria: the place of street lighting will be well planned so that it can provide uniform illumination, safety, and comfort for drive. Clear direction must provide good decision to the driver's vision so that the effect clear and visual is comfort can be reduced. Is this type installation? Yeah, the single lights installation. All automator are placed on one side, left side or right side. Yeah, this type right road when the height of the armature is less the width of they apply to the road would have a wide equal to less than the light height armature. Illumination of the side of armature is greater than upper side of the road. Generally, this type of installation is applied one lane road with two-way restriction. The stagger installation of zigzag. In the stagger installation, the armature position on the both side or right with the pole parallel, left side or side, left side and right side. This type is applied by the width of road 1 or and 1.5 times of the height of armature. Installation should be given to information of the road surface. Taken between light and dark may result in visual discomfort. Generally, this type of installation is applied to the road with two-way traction on one line. Opposite installation. In this type of installation, the armature are located opposite one another and parallel to each other. Yeah. Generally, is applied is the wide is either 1.5 times its armature height. Opposite installation is applied two-way traffic on one road. The twin central installation is the central installation. The armature is applied on the meridian of road. However, the installation also be considered a single side installation for each road. General installation is applied for dual carriageway. Standard of like of the road. We have the table standard normal like is the R1, R2, R3, R1 road and type installation. With concrete and road. This is a table standard to include. Where's the graphic of the commercial utilization with the street, house, and house? The value of fraction of land height is determined as ratio road wide and land height. Yeah. Road wide W2 and W1, W1 and W2. The position of land and road condition. The distance of the travel house is set with W1 as OH, where OH and overhang method. The distance of transport side is W1 W minus OH. W1 is the distance of transport house side in meter, and W the width of road meter. The travel house side ratio is 1 W1 per ha, where W1 the distance of travel house, ha like height, the travel ratio UATSS 1 ha, where the W2 the distance of transport street side H like height. After the house side transport ratio refer to utilization coefficient of height side to curve. Yeah, proof. We can be determined value of coefficient utilization of height side CUSS, and after obtain the street side transport ratio is refer to utilization coefficient of street side curve. You can determine the value of coefficient of utilization of street side CUS. Coefficient of utilization is defined Q equal USS plus USHS, street side and house side, where USS utilization coefficient of street side, USHS utilization coefficient of street house side. The space of between two pole, the calculation of between two pole of street as flux CUFF WE, whereas space of between two pole like flux lumen and lumen, CU coefficient of utilization, maintenance factor, width of the road elimination, the number of pole needed for a road will be given. Length of is PJU street light, yeah, full of street light L for S plus 1, where the Q number of pole, road length, and space of between two pole. Emulation and light intensity. Emulation is defined AFFKWS. Light intensity is defined F equal EWS per CUMFK. Emulation level F like flux and like flux. Lumen coefficient of utilization, maintenance factor, W width of road, space of between, coefficient length. The data width of road, data analysis. Width of road WA 4 meter. The height of human is 7 meter. Analysis. Arrangement of public street lighting. The average road which is 5 and the light of 7 meter. The wide side of the road is lower the height of the luminaire. We chose single side for public street. This is wrong, is 4 meter. Sorry. Determine the value. The surface of the public road will public street lighting will be built is from the rock of cement or cement. From the table wall, normal lighting. So the type of road is collector, housing, television, and belong to the R1 class. Therefore, the elimination is follows. Calculation of space between two pole. we determine from the lamp, the lack of lamp approximately 6,000 lumen, road wide W per meter, coefficient resistance CU 0.2, and lamp lumen interpretation is 0.8 LED, and human depression vector LED 0.9. We have the space of the building to pole is 4 and 43.2 meter. We choose the space is 50 meter. Calculate the number of pole. The space of building pole is 50 meter. The length of the road at 70,340 meter. Number of pole, the sample is Mangalung of district of Kuta Felix, PGWL 1 per L. First one 500 per 50, first one is 358 poles. Calculate of position of utilization with the lamp and street position. And below is the position. Wide of road 4 and distance all from set of your height is 0.75 meter. Distance of another luminaire with W2, WV for H, or X for 0.075 3025. The distance about the pool outside, one or the value of the transition size ratio is W2 U 3.25 per 7. We have 0.46. The value of the transfer street size is 0.46 feet to the portion. The street side, we get the value of resistance from the street side CUSS 0.17. The value of the transfer house side is GTSS W1 X per equal 0.75. We have 0.11. The value of the transfer house outside is 0.11, refers to the resistance coefficient of outside. Sorry. I must the battery. Okay, battery is okay. The house side of the value of the transfer house at 0.77 refers to the utilization coefficient of outside. We get the value of the coefficient of side is CU 0.013. The coefficient of utilization is CU equal CUSS plus CUXS. We have the 0.2. Calculation alike intensity of lamp. Data of public street mentioned A4 lux X luminary X 7 meter W white of 5 and S follow CU MF like this is 505 lumen. We choose the lamp is 1000 lumen. Calculation of battery capacity, power lamp, PL lamp power, PL 40 volt, the less of system 10% PL 1.5 watt load power, PDC, PL plus system, losses, yeah. Losses, power losses 545 watt. Personnel time of personnel 13 hours. Energy for the absorb for loads, we have 155 watt hours. For the system operation, PS12, the OD we chose that's if the freeze 0.8, and capacity of the we need for the battery, we have a DC DODPS 44.4 TX ampere per hour. But the battery we choose the battery of 20 volts, and the capacity of the current battery is 405 ampere hours. Calculated of solar power, based on the data of the insolation, the sunrise, we have the 45 line, and the low and the height is 6.2 to 23 kilowatt meter per day. We chose the 100 as in the low is for 169. We have the capacity of for module 152 and 45 PP. The choice of the panel, solar panel, power of solar panel, the capacity panel we chose 150 per peak. This is the figure of the pool, yeah, 7 meter, and this is the foundation of 40 cross 40 centimeter, deep of 2 meter. The lamp, we chose lamp is 24 and battery, lamp solar panel, ya ini battery. The lamp is 50 watt, is solar cell, is PCR, battery control rectifier, lamp and battery. Thank you.
Thank you very much for your very detailed work. It was very interesting. And I ask the participant if anybody has a question or remark. Not yet. I would like just to ask one question very shortly, because we are almost out of time. That, yeah, perhaps we are living under very different conditions, but in Hungary, in some cases, we have very cloudy sky, where the solar radiation is much lower than in sunny days. So my question that this 13 hours you were used in the calculation, is it enough for one day, or if the sky is cloudy, it is enough for 2 days as well?
Yeah, that is the condition of the weather in the Lombok. Yeah, we have the in the morning, the weather about is bright. Yeah, bright is 6:30, and the afternoon we have the time keep the weather is about around, yeah, black, yeah, about 5:30 p.m. Yeah, it is for the 13 hours, 1 hour. I have a calculation for the charge of battery about 3 hours. It is the light, the sunrise, and the Lombok is very good, I think, for the power panels, solar power panel.
Okay. Thank you very much again for your presentation. And if nobody has any more questions,
Maybe the next time, next time will be two questions to me.
okay.
Thank you, Mr.
Thank you. And then we make a try. Perhaps I call again Liman Hartavan with the presentation about the gyro sensors. I don't know if he could join us or not.
It's already here.
Professor.
Ah, very good.
Hello.
Hello, Professor.
Mr.
Good. Nice to meet you.
Nice to
Please.
meet you again in a virtual, of course. Okay, I would like to
Please,
share
we
my
are listening for you.
Okay, thank you for the time for me to share about my research. It's about design of 2DOF, degree of freedom frame simulator, and making control system with gyro sensor. This the agenda, background, objective, and methodology, result, conclusion, and my acknowledgement. The background is about how the pilot or people who drive in driving simulator can sense how the vehicle motion. I see in one of YouTube channel in flight test from 1932. There's hover plane aircraft, yeah, industrial aircraft try to making a cockpit for racing for remote control for airplane. In 2030, there's hobbies, yes, making a remote control FPV cockpit. And in 2020, there's hobby flight test team making RC cockpit simple. And in my background, the idea is about how to making cockpit, yeah, remote control, can control the remote control car, but in another way, the cars can give a feedback to frame from motion about how the car move in roll and pitch motion. And I see in several simulator, frame simulator, the position of motor, yeah, is not in front but in back or near to position of seat passenger. So I think it's need more motors, need motors with high torque to make this machine. And then so the objective is how to make a frame simulator can move like the motion of the remote vehicle. And I choose motion pitch and roll control to give feedback to frame simulator. And then the other objective is how to change the motor position I hope it can reduce energy or can use motor with low torque. So reduce the energy. This is the position of motor. Okay. I try to put it in the front. So I hope the mass of a body can only several percent in human body, maybe just legs, yes, and foot in here. So the motors can use low torque motor, but still can give motion. Okay. And the methodology is the frame simulator. We try to give us several component to motion. We choose the Arduino and the motor driver, motor, then accumulator to power the system. The steering or the remote, it still control the vehicle, but we add a gyro sensor in remote vehicle to give information to frame how the RC car is moved, in row and pitch. Is another scheme. So in the frame, we have to know how the motion of the frame. So I choose the potentiometer to know the position, the shaft of motors, which this shaft is connected to how the frame is moved, motion, rolling or pitch, and connected to the linkage. And in the car, RC car, we only use sensor gyro to know how the movement in or the motion in row and pitch. In this to scheme is one is in remote vehicle, but in my research right now is only use how the gyro can send command to frame system, frame simulator system. So maybe for the maybe for remote vehicle, I will try to the next research. So I use Arduino and gyro to making a comment to frame system, and then in the frame system there is two motor driver. I use IBT2 that have big ampere, big current. It can pass in this bridge. As I know, the wiper motor is more than 19 ampere. Yeah. So I use the IBT type of motor driver. And the result, after we design the frame, we try to making the frame, and we analyze in a software using SolidWorks. And after we design, we try to realize the frame. So it's only the frame. In other research, next step, we try to complete it, steering wheel or joystick. Yeah, if we want to make this for flight simulator or car driving simulator. We try to how the movement the frame. We use the application in a smartphone to try to know the motion and this pitch up and pitch down. And the conclusion is the frame dimension is about 600 millimeters and 420 in wide and 100 width is 35 kilograms, and with assuming static load on the frame, and people sit in the chair plus with the chair and others, yeah, 150 kilograms. In the analysis of SolidWorks, frame safety can be 1.75 with maximum stress 116. And we check the safety of coupler, and we check the safety factor of the crank, and we conclusion that the structure is still within safety limits. And this is the main control we have designed. We are using MPU 6050 for gyro sensor, Arduino Uno, and for motor driver IBT2 or BTS 7960. And wiper motor it is universal, yeah, for MPV cars. We can buy in stores. And I would like to thank you to LP2M Itanas for my research founded in penelitian dosen media Itanas. Okay, thank you very much. That's all for me.
Thank you very much for your presentation. It was really interesting for me. Yeah, we are very short of time because the closing ceremony is starting these moments, but I think we would save some time for questions or remarks, just a few minutes. Does anybody have a question or remark?
Yeah, I have a question.
Yeah, listen.
Halo, Mister.
Hello.
Ini aku nanya nih. I want a question about this is for wiper ya?
Yes,
Wiper
wiper motor.
for mobile.
Motor, yes.
Yeah.
Using wiper motor.
How about the drive of power of drive the motor ya? What's element or component this a FET or transistor to drive the motor, your motor, yeah, from Arduino and driver LL208. Is this direct to motor or will you have to another you have to to give the another component for drive the motor.
Okay.
What component?
Yes.
FET or transistor?
Yeah. No, I'm sorry. It's just an example. Yes, for the same.
It's dry, right?
Yes, I use the type of BTS 7960. That's one module of motor driver. So I just program the how the current and the power is out using the Arduino.
Yeah. How about the capacity? Is the enough for the drive the motor?
Yes, it's
Is this safety or?
yes, the maximum current is 43 ampere.
What?
But it's only
What
19,
ampere? Yeah.
43 can drive until 43 ampere. Type of BTS.
Yeah, it's enough for
96.
for drive your
Yes,
your
it's
motor.
quite enough.
Yeah. Okay. Thank you,
Thank
Mr.
you, Mr. Nastra. Thank you very much.
Thank you very much. So now I'm really sorry that we are online because I would like to test it personally. One more last question. As I understand well, perhaps you are planning to connect it to a real car and you are able to...
Maybe in next research, Professor.
Okay, good. So I would like to say thank you for you and for all of the lecturers, because we get a message that we should go back to the main room for the closing ceremony.
Excuse me, Professor, we have an additional presenter for today.
Oh.
Yes, one more presenter, maybe Muhammad Rizky Rivaldi.
Okay, sorry for it.
It's okay.
Did not last the last version of that. Then, please come.
Are you ready, Muhammad Rizky Rivaldi or Ibu Dewi Rosmala? Okay.
Halo Bu Dewi, selamat sore. Good afternoon.
Sorry.
Beda euy.
Oh, you should be very fast because they say that the room will be closed.
Okay.
In 45 seconds.
Oh. Okay. You only have time.
Okay.
For next few seconds.
Japanese script.
Yes. Thank
Go
you.
ahead, we see as much as we can.
Yes. I will explain about my research. The title is Implementation of Architecture Linux 5 for Japanese Scripts Handwriting Recognition. So the background is to maintain of Japanese script is needed to maintain the existence and use of regional scripts that it can be supporting factor.
How
Recording
long
in progress.
are you going to speak? You personally. Half an hour? You want to speak in the closing?
Sorry?
How long are you going to speak for the closing?
I will ask to the Parliament Committee, Parliament or the Nuha? Bu Nuha?
Yeah. Good.
Bu Novi? Pak Jasman? Pak Al? Pak Jono? Professor Farkas, there is a meeting agenda. So
Yeah,
if everything is okay.
That's anyway. That's okay.
All right. Ya, Pak.
Actually, it would be also nice if you announce that what are you going to have a deadline for the final paper, for the proceedings paper.
Yes.
What is your plan? To give an offer a deadline for the people.
Dr. Jono or Nuha, maybe you have information about the latest of the paper for the paper.
Yes.
Next one more.
Deadline is important for everybody.
Sure.
We are pressed in time.
2 weeks after today.
Hello.
Hello. Hey.
Hello, Dani.
Hello. How are you? How are you?
Are also there.
I didn't find your paper.
I didn't send.
Oh,
okay, so we will only together.
Sure. Okay.
Okay. Okay, thank you very much, Dr. Dani and Professor Farkas, Professor Horabik, and Professor Isvan Seres as well, Professor Luzana, and also Professor Lubomir Kobik, who has joined in and support our international conference, this Poetic 2021. For the full paper submission, and we will divide it into 2 categories. The first one is for the AIP publishing, and the second one is for our internal, or it will be published by our ITENAS publisher. I mean, it will has an ISBN number, but it will not index it by the Scopus. So to the all of the authors here, of course, for the first category, there will be a charge to publish in the Scopus Index proceeding. We will collaborate with the AIP publisher for this and for this category, and we do hope that for this first category it must be published by February next year. So next year it has to be published published online next February. So we really hope that for all authors who intended to publish in Scopus Index proceeding, because we will have a review and revision and something. So the first we are hoping that we will receive your paper, for your full paper, by next November, and then we will try to review and then revise, and maybe by January it will be all right, and then in February it have met the AIP publisher standard, because we have to meet their standard on publishing. It will take some time for it. So hopefully in 1 month maybe, for those who like to publish in Scopus Index journal, have submitted the full paper to us. Yeah. I'm sorry. Maybe is it by the system or by email for to publish, to submit the full paper? By system. Sorry. All right. Maybe it's much better for all the author to send the full paper to our email. Yeah, to our email. The email is foetic@itenas.ac.id. Maybe Ms. Nuha, could you please write the email in the chat room so people would know this email. And yeah, thank you. Maybe that's for the first category, and then for the second category, maybe it's a bit we have lots of time, but hopefully also for the second category, if it's possible, also in February we want to publish as well. So it's hopefully for it either for the first category or the second category, we are hoping that it will be published in February by next year.
Sounds
Maybe,
good.
yeah.
Sounds good. I think it's a reliable time schedule. Thank you.
Thank you, Prof. Farkas. Yeah, for all the corresponding about this conference, we will use the email for all our. If you have any question or inquiries, or we will use the poetic at itenas.ac.id as our main email. So please do not hesitate to contact us if you need more information about anything about this poetic or the proceeding and everything. Yeah. Okay. Dr. Dhani, maybe
Okay.
we can go on to the session. Yeah.
Okay. Thank you very much, Dr. Jano. Good afternoon, everybody. Professor.
Good afternoon.
Professor Susanna, Professor Horabik, Dr. Lubomir, Professor Seres. Now we are the time to, in the last session, in the second day of the poetic event. As the committee said, this is farewell, yeah, farewell. But I just want to remind for all of you that I just want to remind all of us that the poetic event has been started since 2017. At the time, we began with the international partner, St. Itzman University, the former of the Hungarian University in Agriculture and Life Science. And the second, we have two partnerships, yeah. And the third, we got a lot of the partnership. This is a great moment for us to get a lot of partnership. The first, I would like to thank you very much to the Professor Farkas, Professor Horabik, Professor Lubomir Kubik, Professor Seres, Professor Sana, and all the participants. Yeah, without all of you, I think we can do such kind of the great event. Yeah, just I want to give the opportunity to all the professor here. I think Professor Farkas, for the time, I will give the speech for you because you will meeting. Yeah, I know.
Yeah. Thank you very much, Dhani. And Dhani is really a good leader of the university, not only as a former dean and the vice rector. He knows how to share the duties, so he gave over the speech for me. But anyway, sorry for that. I have an important meeting starting in half an hour. Another one concerning our doctoral school. as a matter of fact, I don't want to talk so long at the beginning when yesterday we opened that Congress or conference. Then I said already my issues. And what I would like to just give you the kind of short evaluation. So first of all, I think on behalf of all of us, we would like to say our deep appreciation and thanks for organizing that meeting again the third time, and especially for the faculty and namely to the Dean, Dr. Jonas Suhartono, and also the rector. She supported. Professor Mevinder is not with us at the moment, as I see, but Danny, who is the initiator of the series, with us continuously, every minute spent with us. And so if I would say the evaluation, a kind of evaluation, I would say that that's the lectures and all those that I took part in personally, the sessions, it was quite reliable, updated topics, and the keynote presentations were sorted out in an excellent way. And what is important, very important, I think the organization was excellent. So if I could say the excellent lectures, excellent keynote presentations, but the organization was really very excellent. If I could say that all together, all of that aspects, if I take into consideration, I would say that this event reached the real the international level. So it's not anymore a kind of local conference. And this is what I think the continuation we had to keep in our mind, and you have to especially don't let it less than this one. I mean, just higher and higher, up and up. So this is the way how the international will also getting a higher and higher scientific position in the world. We are partners, personally, all of us who are sitting here now, and we were invited and having a keynote presentation representing institutions. And as Donny said, it's now extended not only to or 3 institutes, more institutes, including enlarging the conference. And we are to the point when it became a real and international one. So this is the main point what I'm considering. So the continuation is definitely, for me, it's given. So this is a job again for you. And I think that all level, as I mentioned at the beginning, not only the faculty, but also university level is very important. And just I would say that congratulations to all of you. And it was a great success. And let's hope also that, as Dr. Jono explained, that the publication will be, the proceedings will be also a higher level this time. I mean, that's also a very good one. I'm very much supported that one. And what I hope that some of the presented materials, what we heard here, finally initiated that all the young people, especially who are very important to having a high level publication. So this was starting point of the here presentation. They continue and reform it into a journal publication. So if those after that refer back to this meeting and also make it more visible, that conference series. So congratulations, organizational point of view, congratulations on scientific point of view. Go ahead. And as the famous sentence, they say the show must go on. Thank you very much.
Thank you, Professor Farkas. Maybe I forgot one about the statement. Previously, in the first FOITIC, we have decided that the FOITIC is the biannual program. Yeah, and we have choose also that the chairman of the FOITIC is the defense of the dean, but for the international chair, Professor Farkas forever. Okay.
Thank you, Danny.
Okay. Okay. Thank
So
you.
maybe as Danny said it, I would like to remind again that date when we first started to cooperate, it was 2006, so 2006. So it means if you are taking into account 15 years now, 1.5 decade, and the International Drying Symposium, what I organized here in Budapest, and you already attended with this work. So that's long-term cooperation. Okay, thank you.
Thank you. Thank you, Professor Farkas. Professor Joseph Harabik, maybe I would like for you, the opportunity to give speech.
Okay, thank you very much. Professor Dani Rusiravan, and I think it was very good conference. I'd like to wish you to keep the same level for the future, because it's very important to organize such a good international meetings for exchange of the experience between people from different countries, and also different areas of interest. So industry, agriculture, life science, and so on. So it's very helpful for everybody to exchange knowledge between different areas of science. So I'd like to wish you all the best for the future, and please keep this level of conference for the future, and I'd like to wish you all the best. Thank you very much.
Thank you very much. Yes, sir. Now I will move to the Professor Susanna, and the background is the Peter. Hello, Peter.
Hello.
Yeah.
My English is not so good as Professor Farkas, and only shortly. I would like to, on the beginning, to thanks to the Dean of Faculty of Industrial Technology, Dr. Jono Suhartono, for the great event which was prepared on this faculty, and also to the Dr. Dani Rusiravan as a vice rector of the university for this conference preparing, and also to all people which organized this conference, because I think these 2 days was very useful for us and also very interesting. I can say also that the parallel session in which was I the chairperson was very great, very great, because the all presentation was interesting, and many new results held your participants. I would like to also ask you, the future years, we prepare in Nitra the conference Biofi Spring, and I hope we will see someone from this audience in Nitra, and I hope that the pandemic situation will be good, and we will meet you physically, not only online. And I also hope all the people will be healthy in this last year. I think also that say the Professor Farkas that the international level of the conference was very high, and I hope that the BPS NITRA will also have a high level, and the doctoral student in this conference will have nice presentation also. On the finishing, I would like to wish you and your university, your faculty, many success, and in the future. And I hope that this opportunity about we speak with Danny in the parallel room will be really in the future, and I hope also we put some close cooperation in the at the university in the Bandung. I wish you also all the best. Thank you for your attention.
Thank you, Professor Susana. Thank you, Peter. Supporting in background.
Yes, yes.
Now, I would like to give opportunities to the maybe Professor Seres or Professor Lubomir. If you want to say something, please.
Just a few words, thank you, Dennis. So I would like to say thank you for the possibility of participating in your conference. I could hear very interesting presentations and a very wide range from the cancer detection to the solar street light. So it was really good, and I would like to congratulate for your students and colleagues for the very nice presentations. I was happy to be here, and I wish you to continue this level as well. Thank you.
Thank you, Professor Seres. Professor Lubomir, maybe.
Thank you very much. Also, I would like to congratulate the high level of the conference because we have seen a lot of presentation with different level of the research in the nature, and I'm seeing that this research is very useful also for our university, and your experiences are very interesting for us. Our University of Agriculture in Nitra in Slovak Republic, or for our Faculty of Engineering, and mainly our Institute of Electrotechnic, Automatization, Informatics and Physics. So I'm very thankful for your invitation, for very nice organization of the conference, and experiences which are very useful for me. And I would like also, as my colleague, Professor Hlavačová told you, I would like to invite you our conference Biotic Spring in the next year in our department, which are 20 years history, and Professor Farka, Horabik, Hlavačová, Vozarová are the key persons of this conference. So we will very like to see in this conference. I think that the conference in Bandung had a very high level and very nice level, and it is very useful for the Scopus or next databases publications. And I think it is very good for us to cooperate with our university in the level in the education, also in the research. So thank you very much, and I congratulate you to the conference, and I also wish you the best in the future. Thank you very much.
Thank you, Professor Lubomir. I will give opportunities for the participant from the Malaysia or Surabaya, I think, because I have checked non-Bandung. Maybe you can say something.
Hello.
Hello. Okay.
Hi.
Please. Hello.
Hi.
Yeah,
Okay. I'm from Malaysia. Actually, my supervisor is Professor Dr. Husno, Assistant Professor Dr. Husno, and this is actually my first time joining an international conference after years being a research student. But I'm really actually happy to open an eye to participate in international conference with so many professors, so from many countries, and I really learned a lot actually from all the keynote speakers and everything. Yeah, and I think from Malaysia team, I would like to really congratulate the Dr. Dani, Dr. Jono, and all the committee, all the professors. I say thank you. As a student, I learned a lot, and I really I think everyone here, me or everyone, we really learned a lot. And yeah, just a heartfelt congratulations to everyone, and the greatest gratitude to everyone. Yeah, and I hope to join again next time if there is opportunity. And yeah, congratulations and thank you.
Okay.
It's a good one.
You.
Nice.
Thank you, Anas. Greeting from Bandung.
Yeah, makan.
Okay, the other, maybe the last, Dusabe, Simpleste Dusabe. If you, I think you coming from